Good afternoon, my dear students. How are you? Very good. That's good. Welcome to one more session with Infinity Learn, India's largest exam preparation platform. Welcome to you guys. This is Suresh, our Faculty of Chemistry. How are you all, my dear students? Hi. Still students are coming up. Great. That's good. How are you, my dear students? Hello. That's good. Can you able to hear me? Can you able to see me? Sujit. Hi. How are you? Hello. Hi, Sujit. Good afternoon. Great. In this week, we discussed Monday, Tuesday, Wednesday about general organic chemistry. Krishna Sheth, hello. Fatima, hi. Aroshi, hello. Great. Nice to see you guys. In this week, Monday, Tuesday, Wednesday, we had a discussion with general organic chemistry. We had electronic effects. In the next 3 days of this week, we will be discussing about grade 12 topics. And today, we are going to discuss about electrochemistry conclusion class. In the previous week, we had a discussion about the electrochemistry, galvanic cell and electrolysis, and we will just take a snip of this electrochemistry recapture, and we will go ahead with electrolysis and Faraday's laws and also conductivity and batteries and corrosion. Hi Rajput, Suraj Rajput, hello. Good gathering. Shujit Shakht, Fatima, Ayushi, Aruhi Ayushi, Srivatsav. Nice to see those students. I really appreciate those students who are regularly attending the class. Suraj Rajput, Krishna Sheth, Jatavat Shesho, hi beta. So, are you doing work every day that I am giving? I ask you to just join in this Telegram channel, right? There regular notes will be updated and regular homework is also updated. You just go through that, right? All set, go. And welcome to these sessions or YouTube sessions by Infinity Learn, given by eminent professors right from afternoon 12 o'clock to evening 6 o'clock. Physics, chemistry and bio sessions are being conducted. And these sessions are meant for NEET STEP UP program 2025, and total syllabus will be discussed according to a planner, and the plan is also mentioned in this description box. So, you follow that same planner, and these YT YouTube sessions are absolutely free. You can all take advantage of this. So, like the sessions and share these sessions with your friends and make them also get advantage of this, right? And subscribe this NEET channel. Got it, beta? Ha. Quasar, hi, you're new. I can see. Yes, Telegram channel I mentioned here. You please click on it and join it so that you will be getting an updates, right? Quasar, you're new, I know that. So, all students attending here, regular viewers and their regular attendees. So, rule number 1, attend the class regularly. Rule number 2, attend the class with effort. Join the class with pen and book and follow the class and write along with me, and we are going to explain the concept and we are going to make you to do some questions you do with us, and also you will be getting updates. So, follow the updates, follow the YouTube channels and follow the materials that we share in this Telegram channel, right? So that at the end, no doubt you are going to clear NEET 2025, and not only clearing NEET examination, you can be a topper also, beta. You are correct. Yes, total 11th standard and the 12th standard syllabus will be discussed at NEET level. Okay? Yes. What is educational? So what do you want to ask? The question is not clear. Use chat box generously for academic discussions, dear. है ना बेटा? Right. Can you all see me? Can you all hear me? Just give a thumbs up and a fiery emoji so that we can start the class. You are new, Srivatsa. You are new. Right, beta? That's good. So, shall we start? Shall we start? Are you ready? So, in the previous discussion about electrochemistry, this is the lesson 4, session 4 of electrochemistry. Right, beta? Pranita, Pranita, okay, and Srivatsa and Richa Sharma, okay. Talking about electrochemistry, the main concepts that we have: galvanic cell, electrolysis, electrolytic conductance, and corrosion and batteries. These are the 4 major topics that we have. We already completed this. But of course, for those students who just joined, take just a revision of the galvanic cell. So, what is the mantra we have before getting into the electrochemistry? Simply oxidation and reduction. In terms of electrons, what is oxidation and what is a reduction? Arohi, come on, Pranita, come on. Oxidation is loss of electron. Reduction is gain of electron. That's it. So, reduction is a gain of electron that happens at cathode, and oxidation is loss of electron that happens at anode. That's it. So, however, the concept is so big, however, the concept is so complicated, and make it simplified and crafted and given to you. Total electrochemistry, we just talk about oxidation reduction. In one electrode, electrons are lost, and another electrode, electrons are gained. So, let's talk about galvanic cell. So, this is a galvanic cell. It is a spontaneous redox reaction. Therefore, electrical chemical energy is converted into electrical energy. In this, zinc rod is immersed in zinc sulfate, copper rod is immersed in copper sulfate, and these two are connected by using electrical circuit. Hope you are understanding. And these vessels are connected by using a salt bridge. So, what happened? Zinc loses electrons, and it becomes zinc 2 plus, and copper gains the electron, become a copper. Therefore, mass of the zinc decreased and mass of the copper is going to be increased. So, as zinc loses its electron, electrons are moving through external circuit and joining into the copper electrode. That is the reason why the reactions that takes place, zinc loses zinc 2 plus and 2 electrons are lost, become zinc 2 plus, and copper 2 plus that are already available in the form of copper sulfate in this vessel, and electrons are gained and become copper. So, the overall reaction aapka milega, 2 electrons are given by zinc and those electrons are captured by copper. As a result, you will be having copper 2 plus plus zinc gives rise zinc 2 plus and copper. So this is the overall reactions. This is short recapture of galvanic cell that we already completed, my dear students. Hope you are all understanding this. Give thumbs up. Everybody. I want to see my students are with me. The other names for the galvanic cell, voltaic cell, Daniell cell, electrochemical cell, है ना? You have a question, right? So Arohi, you can present your question. You can present your question. So this chat box is especially meant for discussion. Yes. So इलेक्ट्रॉन कहाँ से कहाँ तक जा रहे हैं बेटा? यहाँ पर ऑक्सीडेशन हो रहा है ना, यहाँ पर रिडक्शन हो रहा है. सो जहां पर ऑक्सीडेशन हो रहा है, दिस इज कॉल्ड एनोड है, and this is a cathode where reduction is taking place. Electrons are moving from anode to cathode. That's what is direction of electron flow and direction of current. Electron flow इस तरफ है and current flow इस तरफ है. In the NEET examination, simply, so a simple option will be given. We study this galvanic cell in such a way that we can do any complicated question, but we miss somewhere electron is going in this way or electron is coming in this way. So the statement that is repeated in these options is crafted in such a way that you will get confused. So that you decide yourself, strong determination is required. So electron हमेशा एनोड से कैथोड तक एक्सटर्नल सर्क्यूट से जा रहे हैं. Are you getting or not, beta? Clear? So this particular electrochemistry topic is very important. It carries two marks in NEET examination and 1 mark in JEE examination mains. Okay. Anyways, do hit like button and share with your friends this awesome lecture. Okay. Don't lose your energy. Keep energy in the chat box like that only. And एक बार फायरिए मुझे डालो बेटा, मेरे को थोड़े एनर्जी चाहिए. Okay, Risha, come on. Direction of the current and IUPAC representation. और एक बार बताना चाहता हूं मैं, IUPAC representation हमेशा left hand side anode and right hand side cathode is written. Right hand side cathode is written. So what I mean to say, always IUPAC डांटते रहते हैं हम लोग को. Not only organic chemistry but also inorganic chemistry and also in physical chemistry we have to follow IUPAC guidelines, my dear children. Here now LHS and RHS are separated by salt bridge. This is what you call it as salt bridge, U-shaped vessel. Okay, let us take a quick look at that. Okay, LHS में क्या क्या reaction आ रहे हैं? Zinc is converted into zinc 2 plus. RHS में क्या चल रहे हैं? Copper is converted into copper. Copper 2 plus is converted into copper. So the metal ion and metal are separated by a vertical line, means it is an electrode. And this metal ion and metal are separated by a vertical line. This is an electrode. And this anode and this cathode, left hand side and right hand side, are separated by 2 vertical lines. 2 vertical lines indicates this is a salt bridge. Okay, right? So let's see. What is this salt bridge? This salt bridge is U-shaped glass tube and it is filled with aqueous salt, inert salt, and along with that you have agar gel. Agar gel. Agar gel is a semi-solid material, just like you have just jelly chocolates, right? So that inert salt, what kind of salt you can use? The potassium nitrate. Okay, you can use ammonium chloride or potassium sulfate. You can also use potassium chloride. So what I mean to say, it's very, very important. Ionic mobility of cation should be equal to the ionic mobility of anion. That's very, very important. The speed at which the ion is migrating is called ionic mobility. We will come across with this point. This point you can expect a question from NEET examination, my dear children. So I want to say KNO3, when it ionizes to K plus NO3 minus, so this ion and this ion, both ions migrate with the same speed. What I mean to say, clear madam? That point is very, very important. If you take sodium sulfate, sodium and sulfate migration is different from sodium migration, so you can't use that. Okay, talking about what is the function of salt bridge? Salt bridge complete the circuit. Also salt bridge maintain neutrality. Prevent liquid junction potential. Liquid junction potential means the potential that generated when a particular ion is accumulated around a particular electrode, that is called liquid junction potential, LJP. So you take these very good number of points that I am giving continuously. That's why I strongly recommend, my dear students, maintain a special notebook for each subject and write the notes as the class flow is going on. Okay, my dear students, you are all good students now, so you don't be so selfish. You always make your friends also get advantage of these lectures. Therefore, I strongly recommend you just hit like and share these videos. है ना बेटा? Okay, very good, nice. Yes, give a thumbs up, Epoji. Thumbs up. ग्रेट. मेरे आपका थम्स अप और फायरी इमोजीज देखने का मैं कोशिश कर रहा हूँ. हाँ 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 हाँ. ऋषा हाय. ओके, व्हाट अबाउट उत्तम? उत्तम आया क्या? शेषु, फातिमा, उत्तम, वेर इज उत्तम? ग्रेट. So let's talk about SRP and SOP. So SRP and SOP, standard oxidation potential or standard reduction potential, very very important thing. So बार बार कोशिश करो, ये हमेशा confusion का चीज है. So you don't have to worry. I have a super trick. I have a super trick. What is electrode potential? बस simply when a metal is dipped in its metal ionic solution, ये दोनों का बीच में थोड़ा सा पोटेंशियल जनरेट हो जाएगा. That potential difference, when I touch some surface here, let us say it's a metallic surface, this is air conditioned room, so that when I touch now I'll feel little cold, so that sensation, right? So similarly, when zinc, a neutral, is touching zinc 2 plus as an aqueous media, there is a difference in terms of potential, that is called electrode potential, a single electrode का है ना बेटा. This electrode potential at 1 atm pressure, 298 Kelvin is called single electrode potential. So that क्या यहाँ पर जिंक 2 प्लस का बदलने का कोशिश करते हैं, फिर भी जिंक 2 प्लस जिंक भी बदलने का कोशिश करते हैं. सो दैट यू कैन से द इलेक्ट्रोड पोटेंशियल दैट यू सी इज कॉल्ड ई नॉट. नॉट स्टैंड्स फॉर स्टैंडर्ड कंडीशंस का है, स्टैंडर्ड कंडीशंस का है. सो दैट जिंक लूजेस जिंक 2 प्लस. ए प्रोसेस क्या, जिंक 2 प्लस का बदलना है. So that is an oxidation potential or a reduction potential? जल्दी बताओ शेषो, शेषो, नो नाइस सर, सो नाइस, सो थोड़ा सा ग्रामर का गलत है. जयंत, थैंक यू वेरी मच फॉर योर कॉम्प्लीमेंट, ग्रेट. ऑक्सीडेशन आप सही बता दिया. सो जो प्रोसेस है ना, सो जिस इलेक्ट्रोड पोटेंशियल ऑक्सीडेशन के बारे में पूछ रहे हैं, दैट इज कॉल्ड स्टैंडर्ड ऑक्सीडेशन पोटेंशियल. इफ इट इज देयर, जिंक 2 प्लस is converted into zinc, this is a reduction process. A reduction process का आप is called standard reduction potential. That is called standard reduction potential. This is called standard oxidation potential. Standard oxidation potential, standard reduction potential 0.76 volts. It is going to be plus 0.76 volts. मैं क्या बोलना चाहता हूँ, स्टैंडर्ड ऑक्सीडेशन पोटेंशियल, स्टैंडर्ड रिडक्शन पोटेंशियल दोनों बराबर होता है, मैग्नीट्यूड बराबर होता है, लेकिन साइन वैल्यू बदलते हैं, कंप्लीटली ऑपोजिट. आर यू गेटिंग और नॉट बेटा? फाइन, दैट्स वेरी इंपॉर्टेंट. इट इज, डोंट मेमोराइज दिस वैल्यूज. आई एम टीचर, सो दैट आई मेमोराइज दिस वैल्यूज आई एम टेलिंग यू. राइट बेटा? नाउ this is a golden trick. This is a golden trick. Always you just maintain a cheat sheet before examination. Also you can see and go. For every metal, as SOP value का value increases, I mean to say mathematical value, as SOP value increases, tendency of oxidation increases, so reducing power increases. जिनका reducing SRP value बड़ा है, इसका oxidation power बड़ा है. So like that, simple trick. I am not asking you to take a page of cheat sheet. A cheat sheet means maintain a small formula to cheat the examination question. ओके, गलती करने के नहीं है बेटा, अच्छा करने का. ओके, सो दिस इज ए वेरी वेरी इंपॉर्टेंट पॉइंट. आर यू गेटिंग और नॉट? एनी डाउट्स? जल्दी. ओके, measurement and all, we did these things. Okay, now talking about, we all completed these things in the previous class. Okay, Nernst equation also we completed in the previous class. Remember what is Nernst equation? Nernst equation is the equation we calculate electrode potential at given concentration. So that is given as simple. I'll explain it. This is kept as notes for your reference. So electron motive force for the cell is equal to electron motive force standard conditions minus, okay, RT by NF ln QC. What is QC? जल्दी बताओ. What is QC? जल्दी बताओ. QC is reaction quotient. QC is reaction quotient. Okay, so for zinc, copper 2 plus gives rise zinc 2 plus and copper, which is a solid. So QC is written as zinc 2 plus and copper 2 plus, है ना? We discussed this. R value is 8.314, T is 298, F is 96,500. Ravindra Reddy, reaction quotient. So reaction quotient and equilibrium constant दोनों का क्या फर्क पड़ता है बेटा? रविंद्र रेड्डी, so welcome to the class. What is the difference between reaction quotient and equilibrium constant? Are these two are same? That's my question. एक मिनट. Yes. So Ravindra Reddy, are you there in the class? You just give a response. What is the difference between reaction coefficient and equilibrium constant? Okay, the equilibrium constant K differs from reaction quotient. In that K uses concentration at equilibrium, while Q can use the. Ravindra Reddy, your answer is absolutely perfect. So reaction quotient and equilibrium constant both are, as concept is same, but the way these two are used, the situation is different. At equilibrium, Kc is equal to Qc. Okay, if Kc is not equal to Qc, the reaction is not at equilibrium. I know Ravindra Reddy, that's why I said welcome to the class, hai na? Before, I know all the students, hundreds of students are there in the current class. I remember many students names. Sheshu is a regular student, a very good student here, and Richa Sharma and Ishita, we can see Fatima. Fatima is there, na? Hi, say hi, bolo. A new student is joined today, Ravindra Reddy. Fatima is there. Uttam he is not there today. Okay, Panita, regular attendee of the class. Okay, let's go. So, if you take R value as a constant, T value as a constant, F value as a constant, E cell is written as E naught cell minus 0.0591 by N log to the base 10 of QC. Okay. Here I'll tell you one simple trick. किसी का मत बोलना, सिर्फ मैं आपका दे रहा हूं. ये वैल्यू जो है ना 0.0591 ना 06 ले लो. ओके, कुछ फर्क ना पड़ता. आंसर का जो आंसर मिलेगा ना, हाय फराज आलम, हेलो. हाँ, मैं वो बता रहा हूँ ना आलम. So if you take 0.0591, you want to divide with something ना, पागल हो जाएगा ना. So 0.06 if you take generally for those electrochemical reaction 1 electron, 2 electron, 3 electron तक आ जाएगा. So divide with n is equal to 1, कोई प्रॉब्लम नहीं है. If you want to divide with 2, 0.03 आएगा. If you want to divide with 3, 0.02 आ जाएगा. समझे? सिंपल 0.06 ले लो, एग्जामिनेशन में आपका अच्छा होगा. सिंपल ट्रिक. सो सिंपल ट्रिक मीन्स इट शुड बी सिंपल, है ना. समथिंग आई डू एंड मेक इट कंफ्यूज एंड छोटा सा फॉर्मूला बना के आपका ऊपर छोड़ देते हो तो सिंपल नहीं होगा ना. द स्मार्ट वे, सिंपल मीन्स स्मार्ट वे. ओके, कम ऑन, नेक्स्ट. So this what we discussed already. This is the one. Equilibrium constant from the Nernst equation. Equilibrium constant from the Nernst equation. This is very important. In the NCERT also it is given. What is equilibrium constant? Kc, zinc, copper 2 plus, zinc 2 plus and a copper. इसका QC, zinc 2 plus and a copper 2 plus. What is Kc? फिर भी zinc 2 plus and a copper 2 plus. हमारा जो Nernst equation है ना, that is E cell is equal to E naught cell minus 0.0591 by N log QC. When you go with thermodynamics, you don't look at here. If delta G is negative, the reaction is spontaneous. If delta G is equal to 0, the reaction is at equilibrium. If delta G is equal to positive, the reaction is non-spontaneous. Okay. So, at equilibrium what happens, you know? At equilibrium the condition आ जाएगा आपका QC KC का बराबर होता है 5 minutes पहले आपको बता दिया. Okay, Ravindra Reddy, in the chart box Ravindra Reddy is also given the same, right? Now at equilibrium में क्या बोलना चाहता हूँ, QC and KC का बराबर होता है. And one more important point है कि so देखो डेल्टा जी इज नेगेटिव मीन्स स्पॉन्टेनियस, तब आपका ई सेल पॉजिटिव होगा. डेल्टा जी इज पॉजिटिव मीन्स ई सेल नेगेटिव होगा. इट इज नॉन स्पॉन्टेनियस. जब आपका इक्विलिब्रियम आएगा ना, Kc इज इक्वल टू Qc एंड ई सेल इज इक्वल टू 0. When the battery is inserted into the machine, it will work. इसका E cell positive होगा. When the machine is not working, battery खत्म है. You say battery do not show voltage, delta G is 0, equilibrium में है. So अभी that's what. Good afternoon beta. So this is a normal thermodynamic equation, thermodynamic data. Okay, abhi you just see, when the system reaches the equilibrium, you have a battery here. You all have the remote controls, right? We use the battery in the remote control. We use it because chemical reactions are taking place, and you connect to this to the voltmeter. It is going to give you 1.5 volts. When this remote control stops working, na, you take out this battery and connect to the voltmeter, it shows 0. Voltmeter value 0. Understand? Are you getting or not? Nobita. Help. I am here to help you, my dear students. The voltmeter shows 0. So when voltmeter shows 0 at equilibrium, voltmeter का value, that is EMF of the value is 0. This value is 0, है ना? And the system is going to be at equilibrium. अगर equilibrium होना तो QC is equal to KC. QC is equal to KC. Therefore 0 is equal to E naught cell minus 0.0591 by N log Kc. This equation is changed to this equation, so that log Kc, I just want to take this side, log Kc is equal to N E naught cell minus 0.0591. Got it? So this equation you can directly use in the NEET examination as a formula. Make a cheat sheet. Jaldi likho beta. Great. Jaldi likho. This equation we simply by heart it. How did it come? The situation is important. This is actual Nernst equation. हम equilibrium constant is 11th standard equilibrium chapter का है, लेकिन Nernst equation 12th standard का electrochemistry का है. ये दोनों एक बार लिंक भी है. कौन लिंक करेगा? thermodynamics लिंक करेगा. thermodynamics कैसे लिंक करेगा? ये लॉजिक का हिसाब से. Are you getting or not? Clear बेटा? चलो. So these are all we did in the previous class. एक बार रिवाइज करना चाहता हूं, जल्दी जल्दी कर लो बेटा. Next, maximum reversible work done by a galvanic cell is given by minus NFE cell, or you can also say delta G naught is equal to minus NFE naught cell. And this is very important thing. Thank you. Very important thing I want to give you. जो भी एग्जामिनेशन आप लिखने का कोशिश करो, let it be NEET, let it be IIT, one question I just want to discuss, one concept related to that question. Let us say a metal is converted into metal X plus by loss of X number of electrons, N1 number of electrons, and metal X plus Y plus बन गया N2 number of electrons निकाल के इससे. And let us say this metal can be converted into My by loss of N3 number of electrons. Got it? Let us say copper plus say copper 2 plus. Got my logic? Clear beta? Now for this electrochemical reaction ka, let us say this is E1 electrode potential. For this E2 electrode potential. For this E3 electrode potential. My dear students, carefully when you attend these YouTube sessions, फायदा उठाने की कोशिश करो. ओके, मजा लूटने का कोशिश करो. I can guarantee you definitely you will be getting a question. If you get the difficult and the most difficult question, you will get the question from here itself. अरे I know that it is यहाँ से यहाँ तक E1 है ना, यहाँ से यहाँ तक E2 है ना, यहाँ से यहाँ तक पूछेंगे तो क्या करें अब? E03 is equal to E01 plus E02. If you think like this, I simply say ये गलत बात है, wrong. सही सीखने का पहले उसमें गलत क्या है सीख लो पहले. This is wrong because electrode potential, single electrode potential, जो भी SRP और SOP, they are not additive. Means you cannot add. thermodynamics में additive properties, non-additive properties. जो values है ना, ये add कर सकते हैं. They are called additive values. Electrode potentials are not additive properties. कई हाल में रखो. Whereas delta G values are additive. यहाँ पर मैं लिख के देता हूँ. E0 values are not additive. ये खतरनाक स्टेटमेंट है. E0 values are not additive. बस. Whereas delta G0 values are additive. ऐड करने के परमिशन है. Therefore, इसका मान लो डेल्टा G01 है, डेल्टा G02 है, ये डेल्टा G03 है ना. सो डेल्टा G03 is equal to डेल्टा G01 प्लस डेल्टा G02. ये सही है, करेक्ट. उसमें गलत बात क्या? ये गलत बात है, ये सही बात है। समझ में रखिए बेटा रविंद्र रेड्डी, स्टैंडर्ड रिडक्शन पोटेंशियल एसआरपी एंड स्टैंडर्ड ऑक्सीडेशन पोटेंशियल एसओपी आर इक्वल इन मैग्नीट्यूड, ऑपोजिट साइंस ravindra reddy, that is correct. So minus n3 f E03 minus n1 f E01 plus minus n f E02. You can say E03 is equal to, okay, minus n3 E03, and you can mathematically manipulate this. It's super clear. And from here क्वेश्चन कैसे दे सकते हैं नीट में? इसका E1 देते हैं, E2 देते हैं, E3 पूछना है, E1 E3 देना है, E2 पूछना है। एनी 3 वैल्यूज में 2 values will be given, 1 value will be asked. If you get the toughest of the toughest question from the NEET examination, this is the concept you can get it. Okay, this is there in the NCERT, but it's not explained here. If you open any kind of books, better you just follow the program given by Infinity Learn. It is well crafted one. Okay, so in the NEET 2024 exam हुआ था ना, हमारा जो मटेरियल है, ये मटेरियल से 100% ऑफ द क्वेश्चन एनालाइज करने के बाद मैं बोल रहा हूं 100% ऑफ द क्वेश्चन हमारा श्री चैतन्य इन्फिनिटी लेंथ से मटेरियल से आ चुका। ठीक है, प्रैक्टिस क्वेश्चंस कैन, यस यू कैन गिव इट आल्सो रविंद्र रेड्डी। सो दिस इज योर फर्स्ट क्लास ना, आपको थोड़ा सा शुरू में ऐसा लगे, बट विल डू प्रैक्टिस क्वेश्चंस आल्सो। ओके, एनी डाउट? टेक ए स्नैपशॉट ऑफ इट, जल्दी करो फटाफट। Come on. Next. If E cell for a given reaction has a negative value, then which of the following gives the correct relationship for the following delta G and EQ? Negative value means delta G is going to be positive. It is a non-spontaneous. Is a non-spontaneous. समझ में आ रहा है क्या? Got it? रविंद्र रेड्डी, आप जब पूछेंगे ना, एक क्वेश्चन निकल गया। So equilibrium always go in this backward direction than the forward direction. कोई equilibrium is less than 1. Okay? So what is the correct answer? What is the correct answer? What is the correct answer? रविंद्र रेड्डी, क्वेश्चन आपके लिए पेश कर रहा हूं मैं। हाँ, यस इट इज ऑप्शन 1। दिस इज द एक्सप्लेनेशन इन द नीट एग्जामिनेशन। अरे यू जस्ट सी हाउ द कॉन्सेप्ट्स आर बीइंग इंटीग्रेटेड। ई सेल इलेक्ट्रोकेमिस्ट्री का, डेल्टा जी थर्मोडायनेमिक्स का, इक्विलिब्रियम कांस्टेंट इक्विलिब्रियम का है। So 11th standard 2 chapters and 12th standard 1 chapter, grabbed it, एक क्वेश्चन फ्रेम किया जाएगा। So students feel it is easy, students feel it is difficult, students feel it is moderate, a perception है, it is simply absolute perception. So no need to say this question is easy, a question paper tough है, question paper easy है। After you say every year question paper tough or easy only for the sake of discussion, after doing all these things you will feel the question paper is going to be super easy. Okay, so अच्छा, अगर अच्छा तरफ अभ्यास करेंगे तो आपका क्वेश्चन पेपर इजी लगेगा। ओके, अच्छा तरफ अभ्यास नहीं करेंगे तो क्वेश्चन पेपर में थोड़ा उल्टा फुल्टा होगा। हाँ, के इक्विलिब्रियम कांस्टेंट, equilibrium constant means beta, that is Kc. Sheshu, now you understood. Now you understood, right? Give thumbs up emoji. हाँ, Yes. If you have a Kc or Kp, they are called equilibrium constants. Kc is equilibrium constant in terms of molar concentrations, Kp is equilibrium constant in terms of partial pressures. ठीक है बेटा. Now आगे बढ़ेंगे. Concentration cells. Concentration cell. So concentration cell is a cell where you can see copper is immersed in copper sulfate. Copper is immersed in copper sulfate. This is at say C1 concentration at C2 concentration. अगर different concentrations में होगा तो okay, these two are connected by using salt bridge. So this is our salt bridge and it is connected by using external circuit. समझे? So this experiences some electrode potential, this experiences a different electrode potential. So same electrode and electrolyte but different concentrations. So उसमें electrode and electrolyte same है ना, so that EMF is equal to E0 cell minus 0.0591 by N log C2 by C1. So इसका वैल्यू 0 लेना चाहिए. That's what I want to say because electrode same. जब तक electrode same है आपका E0 वैल्यू सेम ही होगा. Concentration cell in which the electrolyte is same. Ravindra Reddy, correct? So you need not have to retract the message. So it's correct. That's correct. So that's what is said. These concentration cells is electrolytic concentration cell, electrode concentration cell. Electrolytic concentration cell, you use C1 and C2 concentrations, and the electrode concentrations P1 and P2 partial pressures. So partial pressures are different. Here concentrations are different. So I just want to say here the thing is E cell EMF is going to be minus 0.0591 by N log C2 minus C1 क्योंकि यहाँ पर in the previous one the same thing is given here. This if C2 is greater than C1 then log C2 by C1 is going to be positive, then E cell is going to be positive. Then cell can give electromotive force. Otherwise, avatar the same. You just see I'm just avatar when an electrode immersed in electrolyte, it experiences some potential. Na? This is based on concentration of the electrolyte. If you take one more electrolyte, ये दोनों में concentration में थोड़ा difference होगा तो ये electrode potential को value, ये electrode potential का value जो अंतर होता है ना, that difference in the electrode potential is a potential difference due to concentration in the electrolyte, that is called concentration cell. Avatar in a single statement I have given, right beta? Clear? So now you can't say you don't understand, you understood. ठीक है बेटा. और एक बार देखो, अगर पार्शियल प्रेशर है ना तो ये भी ऐसा होगा E is equal to minus 0.0591, ये 5 है, okay, upon N log you take P1 and P2. P1 is greater than P2. The partial pressures are taken in this case. Of course, this concentration cell NEET एग्जामिनेशन में इतना काफी इंपॉर्टेंट नहीं है, लेकिन अगर एक कॉन्सेप्ट का बारे में क्वेश्चन पूछेंगे तो यू शुडंट रिग्रेट दैट द क्वेश्चन इज आस्क्ड. दैट्स व्हाई आई जस्ट वांट टू गिव एक्स्ट्रा एज. सो ये यूट्यूब सेशंस सिर्फ रेडियो सेशंस नहीं, माय डियर चिल्ड्रन. वी आर प्रिपेयरिंग ए ग्रुप ऑफ डॉक्टर्स इन नीट 2024 एग्जामिनेशन, राइट बेटा? ओके. So thermodynamics we discussed, okay, electrolysis. Clear? That's electrolysis. This is also discussed. Decomposition of a compound by passing electricity through electrolyte is called electrolysis. This electrolysis, you can say, we use for the aqueous solutions preferential discharge theory. If more than one ion is present, which ion has to be discharged based on preferential discharge theory. In the presence of more than one ion in the electrolysis of the aqueous solution, you have to follow preferential discharge theory beta. Electrolysis is the process of using electricity to split or decomposition into its constituent elemental substances. Ravindra Reddy, that's good. You have given water, hydrogen and oxygen, that is also correct. You are taken as an example. Next chapter, अभी यो chapter अवतार ये chapter खत्म होने दो भैया, बेटा एक चैप्टर पहले खत्म होने दो, बाद में कौन सा चैप्टर चाहिए आप बोलो, मैं शुरू कर लेता हूं. ऑर्गेनिक ठीक ठाक चल रहे हैं अवतार? अरे पूछने का तो आप आंसर देना बेटा. हाँ, दिस पर्टिकुलर सेशंस weekly 6 days the sessions will be there. First 3 days I give 11th standard topics and the next 3 days I'll give 12th standard topics. Today I am going to finish electrochemistry, okay, and tomorrow we will connect to the organic conversions. Organic conversions we completed, उसमें कैसे master होना, okay, that we are going to discuss in tomorrow's class, है ना. फिर सैटरडे से सॉल्यूशंस एंड कॉलिगेटिव प्रॉपर्टीज शुरू होगा बेटा. ठाकुर संतुष्ट है? जो भी क्वेश्चन है चार्ट बॉक्स में, जो क्वेश्चन सिर्फ आपके लिए एड्रेस किया जाएगा, ठीक है, स्पैमिंग मत करना, चार्ट बॉक्स जेनरसली इस्तेमाल करो, इंटरेक्ट विथ मी, टॉक टू मी एंड लेट अस रेज ये गुड कॉन्सेप्ट्स एंड गुड क्लैरिटीज. जो आपका डाउट है सभी का होगा और दूसरे बच्चा का भी होगा ना, राइट बेटा. सो लेट्स सी, दीज पॉजिटिव चार्ज का डिस्चार्ज है सोडियम, मैग्नीशियम, एल्यूमिनियम, हाइड्रोजन, कॉपर 2+, ये हार्ड रहे, थोड़ा सा ख्याल में रखने का कोशिश करो बेटा. ओके, रट्टा मारना का एक्चुअली आई एम अगेंस्ट टू दैट, बट यू कैन, बिकॉज in the presence of aqueous solutions, na, these are the ions. In the presence of aqueous solution, जो भी ions ये डिपॉजिट नहीं होगा. In the presence of aqueous solutions, ये ions नहीं डिपॉजिट होगा. Simple trick, simple trick. Got it? In the presence of aqueous, active metals do not deposit. Okay, talking about in the aqueous solution, electrolysis by using inert electrodes. What is an electrode? Electrode is a metal rod that is dipped into the electrolyte. This electrode is of two types. One is inert electrode, another one is active electrode. Inert electrode means the electrode that do not react. Actually, it's conduct, that's it. इसका कुछ रोल नहीं है. इनर्ट इलेक्ट्रोड का हमारा जो एग्जांपल, प्लैटिनम इलेक्ट्रोड इस्तेमाल कर सकते हैं, निकल इलेक्ट्रोड इस्तेमाल कर सकते हैं, ग्राफाइट इलेक्ट्रोड इस्तेमाल कर सकते हैं. ओके, अटैकिंग इलेक्ट्रोड मींस सो एक्टिव इलेक्ट्रोड, सो कॉपर मेटल इन कॉपर सल्फेट, लाइक दैट. ओके, टॉकिंग अबाउट sodium chloride, okay, is electrolyzed. Two things in molten state. So in molten state, one is plus, another one is minus. If a sodium chloride is electrolyzed in the molten state, it gives rise sodium plus and Cl minus. So these are the ions. So that Cl minus and sodium plus. Sodium plus is a positive ion that is attracted towards the negative. Cl minus is a negative ion attracted towards the cathode. है ना? Ravindra Reddy, what you said is correct. So that this is a cathode, sodium plus takes an electron, gives rise sodium metal is deposited, whereas at anode Cl minus loses electron and Cl2 gas is liberated. So when molten state of sodium chloride is done, chlorine gas is at anode, sodium metal is at cathode or deposited. If we talk about an aqueous solution, ये चीज कैसे होगा? NaCl aqueous में क्या क्या आयन्स तैयार है? Na प्लस Cl माइनस, aqueous है ना, H प्लस and OH minus. So if we go to the previous one, for positive ions, Hu plus is more likely to be discharged than sodium plus. Therefore, what happened? Hu plus is going to be deposited but not sodium. Are you getting or not? Are you getting or not? Clear? Now, Cl minus OH minus में क्या क्या चल रहे हैं? Cl minus पहले डिपॉजिट होगा OH minus आयन से. Therefore, you are going to say OH minus ion won't be deposited. OH minus ion is not going to be deposited. Rather, Cl minus is going to be deposited. Therefore, at cathode, H plus takes an electron, gives rise hydrogen gas, and anode Cl minus loses electron and gives rise chlorine gas. So, the products that are generated, chlorine gas, hydrogen gas in the aqueous media, whereas sodium metal and the chlorine gas in the molten state. That is the difference you need to know, my dear students. Hope you understand. Thakur, come on, got it? Clear? एक thumbs up देना यार कम से कम. हाँ बेटा हाँ, perfect, perfect, great Ravindra Reddy, that's good. शेषु कहाँ गए तू? शेषु where are you? मैं ढूंढ कहाँ होंगे क्या? Richa, that's good. Come on, आगे बढ़ेंगे थोड़ा. Great बेटा, great, great, great. So, talking about attacking electrolysis by using active electrodes. Active electrodes जो है ना, also called as attacking electrodes. You just see a copper metal is immersed in copper sulfate. In this copper sulfate. So copper is deposited in copper sulfate. So these two are going to react. So that is what you call it as attacking electrodes or active electrodes. In this attacking electrodes, you are having an anode and it is cathode. So what happens at anode? Copper, which is a solid, loses electrons to give rise copper 2 plus. At cathode, copper 2 plus aqueous take electron, gives rise copper. which is in the solids. That's the reason why here it is happening. This copper anode is going to decrease its mass. Gradually इसका mass decrease हो जाएगा. Whereas it is going to increase its mass. That's what is happening. Electrolytic refining of the metals, we do this, huh? Avatar, attacking electrode means, active electrode means जो electrode ये रिएक्शन में इन्वॉल्व किया जाएगा, क्योंकि ये मेटल कॉपर एंड इसका आयन दोनों में कॉमन होना चाहिए. ओके हर्ष बेटा, हेलो. Avatar, is that fine? I am not going to already. If a student, can you repeat it, sir? I don't understand means I'll take it personally and I'll go till end to make the student get understand. That is my nature. Hi Sheshu, ho, thank you. Clear, Santush beta. Okay, come on. हर्ष क्या पूछना चाहता हो? Excellent boy. Harsh, what is your question actually? K2Cl2 वो K2Cr2O7 है. ओके Cr2 O3 भी है. Cr ओके अब क्या पूछना चाहता हूँ? ओके लीव इट. No. Your question is not clear, and of course it's not related to current context. Let us see it later. Come on. So Faraday's first law. Faraday, Michael Faraday. You know about Michael Faraday? He is a scientist. Okay, he is actually a book binder. When people comes and makes him to bind the books, he used to refer the books and he used to read those books and he written theorems in this. Such an intelligent fellow. Such a hard working fellow. है ना बेटा? What is aldol condensation? Excellent boy. Aldol condensation comes in carbonyl compounds. That will be definitely explained when that particular concept comes in आज का class ना है बेटा. Okay? Faraday's cage. Faraday's cage you want to know? Okay. So let us talk about Faraday's law. Then we'll talk about the Faraday's cage. Okay? First, Faraday's is given laws of electrochemistry, Faraday's first law, Faraday's second law. So Faraday's first law says, अब जितना electricity current pass चाहे, when you pass electrolyte current charge into the electrolyte, the amount of substance that is deposited, here chlorine is depositing, here hydrogen is depositing. So how much amount of the chlorine is deposited, that depends on how much current you are passing into it. That's it. So I mean to say, that is the mass of the substance that is deposited is directly proportional to the quantity of charge passed through the electrolyte. Sheshu, yeah, you have practice MCQs based on this. Yes. Laws of electromagnetic, this Faraday khatarnak hai. He has given laws in physics, laws in chemistry also. The same insan hai. Okay. So let's talk a part of chemistry and we'll discuss it. ठीक है बेटा? So weight is directly proportional to IT. Directly proportional to IT. I stands for current and the T stands for time. So I want to say W is equal to Z is a constant IT. What is Z beta? Z. Jayant Reddy, tell what is Z? What is Z? Electrochemical equivalent. Electrochemical equivalent. That's good. Electromotive force nahi hai beta. Electrochemical equivalent. How do we define this electrochemical equivalent? जब आपका I 1 ampere and T 1 second होगा तो, so then Z is equal to W. I mean to say the mass of substance that deposited when 1 ampere current is passed through the electrolyte for 1 second. Simple. अब कहिस ना, right? सो दिस इज वेरी वेरी इंपॉर्टेंट. एक डेफिनेशन का हिसाब से भी एक क्वेश्चन आ सकते हैं नीट एग्जामिनेशन में. ऑलवेज बी कॉन्फिडेंट इन डेफिनेशंस, ऑलवेज बी कॉन्फिडेंट इन फॉर्मूलास, ऑलवेज बी कॉन्फिडेंट इन चीट शीट्स. समझे बेटा? सो दैट्स व्हाट इट इज सेड. सो यू ऑलवेज यूज दिस फॉर्मूला टू कैलकुलेट द मास ऑफ द सब्सटेंस. ख्याल में रखो, जो टी वैल्यू है ना सेकेंड्स में लेने का कोशिश करो. इफ यू टेक इन मिनट्स आपका गलती आंसर मिलेगा. ओके, सो यू कैन ऑल्सो से W is equal to atomic weight into I into T upon N into 96,500. Why this 96,500? That is the charge carried by 1 mole of electrons. 1 mole means 6 into 10 power 23. Charge of electron means 1.6 into 10 power minus 19 coulombs. If you multiply, you are going to get roughly approximately 96,500. समझ में आ रहा है क्या बेटा? What that is called, Ravinder? Yes, absolutely. Great response in the chat box. I am really enjoying with that. लगे रहो बेटा. हाँ. In mole concept, you learned it. Yes, you learn these things there, those things here. Okay, सही बोला आप. Okay, अरे you can say this is very important. You see, number of moles of the substance that is deposited can be calculated based on this formula. If you calculate number of moles, no, you can calculate the volume of the gas. Volume of 1 mole of gas is equal to 22.4 liters at STP. समझे बेटा? So calculate the volume of gas that is obtained. You can calculate from this particular formula. So cheat sheet आप खुद बनाओ बेटा. सभी क्लास का सारा नोट्स आपको मिलेगा. Given here Telegram channel in the chat box. You can click on this and you can join the Telegram channel and you will get updates of the sessions. You will get lesson materials. And you can also get the other questions and assignments in the Telegram channel. And also a Google form is given, you fill it, your data will be captured and we only will send you the recent digitalized updates in that. ठीक है बेटा? Are you getting or not? हाँ, in the Infinity Land we are providing all these services on YouTube platform for absolutely free. You need not have to pay anything better, but only one thing we are requesting you, just एक बार like मारो and share and subscribe. Ravinder, it is standard temperature and pressure. Okay, जोश ऐसे रहना चाहिए बेटा. Okay, Ravinder Reddy, very good. All the students, you please maintain the same Josh level so that I also feel myself more enthusiastic and I'll give a double energetic class in a super awesome manner. Right, beta? Are you with me? एक बार thumbs up दे and fire emoji देना. चलो, come on, waiting for you. Faraday's second law, and it is an application of Faraday's first law. Come on, waiting for fire emoji na. Thank you, Ravinder, thank you. Now, so this is a electrolyte, this is another electrolyte, this is another electrolyte, and these electrolytes are connected in series. Physics में अगर series में connect होगा तो इसमें quantity of charge passed is equal to quantity of charge passed is equal to quantity of charge passed, है ना? So when equal quantities of charge passed, उसमें हाइड्रोजन मान लो यहाँ पर हाइड्रोजन डिपॉजिट किया जाएगा, यहाँ पर कॉपर डिपॉजिट जाएगा, यहाँ पर सिल्वर डिपॉजिट किया जाएगा. सो ये क्या बोल रहे हैं? सो द वेट ऑफ हाइड्रोजन डिपॉजिटेड is to weight of copper deposited is to weight of silver deposited is in the ratio of equivalent weight of hydrogen is to equivalent weight of copper is to equivalent weight of silver. That's what is said. When equal quantity of electricity is passed through the electrolyte that are connected in series, the amount of the mass of the substance that is deposited at respective electrodes are in the ratio of their respective electrons equivalent weights. That's it. समझे बेटा? That is Faraday's laws of second law of Faraday. So one more important point, actually this is not that important for NEET. Extra edge के लिए दे रहा हूँ मैं current efficiency. You usually don't need it if it is asked at the last minute. So you need not have to regret na. So current efficiency क्या? Actual mass divided by theoretical mass into 100. So theoretical mass क्या? हम जो एक्सपेक्ट कर रहे हैं ना थियोरेटिकली दैट इज एंड एक्चुअली आपको कितना मिला, सो दैट इज कॉल्ड करंट एफिशिएंसी बेटा. ठीक है, ठाकुर अवतार ठाकुर, गॉट इट, फाइन. नाउ फॉर द सेकंड लॉ, दैट्स व्हाट इट इज. कंडक्टेंस, द कंडक्टेंस. सो व्हाट इज कंडक्टर? द सब्सटेंस व्हिच अलाउज द passage of current through it is called conductor. This conductor is of two types. This conductor is of two types, electronic conductor and electrolytic conductor. Electronic conductor means आपका कॉपर वायर है, ओम्स लॉ चलेगा उसमें. ओके. इलेक्ट्रोलाइटिक कंडक्टेंस, एग्जाम्पल आपका सोडियम क्लोराइड एक्वियस, उसमें ओम्स लॉ ना चलेगा, कोल्ड्रास लॉ चलेगा. अंडरस्टैंड? यस. सो लेट अस टॉक अबाउट इलेक्ट्रोलाइटिक कंडक्टेंस. सो द कंडक्टेंस फिजिक्स के हिसाब से इट इज द रेसिप्रोकल ऑफ द रेसिस्टेंस. ओके. सो रेसिस्टेंस is directly proportional to length. L stands for length, and resistance inversely proportional to area of cross section. I just want to say resistance is proportional to L by A, so that resistance should be equal to, there is some constant called rho. Rho is called specific resistance. Specific resistance, that is RA by L. Ohm centimeter is the unit. Very simple methods I am giving. Okay. Conductance is the inverse of the resistance, है ना? Conductance is the inverse of the resistance. Ravindra Reddy, yes, correct. So हम जो एक resistance है ना, that is rho L by A. You can say 1 by rho. You can say specific resistance, specific conductance. Specific conductivity is the inverse of specific resistance. Specific resistance जो है इसका inverse L by A into 1 by R. Are you getting or not? Clear? That's fine. So this is known as specific conductance. You can use by using kappa. K, it is kappa is equal to L by A into 1 by R. L by A is equal to G star, is also called as cell constant. So that you can say G star into 1 by R is equal to, it is resistance. This is what you call it as a specific conductivity. This specific conductivity means the conductivity offered by one centimeter cube electrolyte, okay, and its unit is Siemens centimeter inverse. Siemens centimeter inverse, this is very 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 important point. This is about specific conductance, इससे भी क्वेश्चन निकलेगा. So specific conductivity से आप equivalent conductance कैलकुलेट कर सकते हैं और molar conductance भी कैलकुलेट कर सकते हैं. So any doubts, my dear children? Any doubts here? Come on, come on. For electrolytic conductance, Faraday's laws is given relation between the charge Ravindra Reddy and the substance. But laws of conductance here, how much the quantity? So Goldrush law, not Faraday's law. समझे बेटा? That's great. That such an involvement, Ravindra Reddy, I am really appreciate. Okay, come on. So let's talk about molar conductance. Molar conductance means the conductivity offered by 1 mole per liter of electrolyte. That is called molar conductance. It is indicated by this symbol. Okay, if this symbol is given, molar conductance at a given molarity or given concentration, or you can see the molar conductivity, I just want to write 0. Okay, so when the concentration is 0 or infinity dilution, so molar conductivity or limiting molar conductivity, you can say 0 concentration. Limiting molar conductivity. Molar conductivity is equal to specific conductivity into 1000 by molarity. Khatarnak formula hai. You can do 100 numericals based on this. More than 100 numericals from any other material. Let it be any material. और यू कैन से इन कॉन्ट्रास्ट जब आप मोलारिटी इस्तेमाल कर रहे हैं ना, ये मोलर कंडक्टिविटी होगा. अभी आप नॉर्मलिटी इस्तेमाल करो, ये इक्विवेलेंट कंडक्टिविटी होगा. इक्विवेलेंट कंडक्टेंस मोलर कंडक्टेंस के जैसे है ना. सो द कंडक्टिविटी ऑफर्ड बाय वन नॉर्मल सॉल्यूशन. क्लियर बेटा? सो नॉर्मलिटी का मोलारिटी का रिलेशन है क्या? Molarity into n factor. Molarity into n factor. How the mathematical equations are manipulated? Let us say molar conductance is equal to K into 1000 by molarity. समझे बेटा? समझे बेटा? समझे? Right. So do you mind if I multiply this with n factor upon n factor? N is the factor here. दोनों मिलके आपका आएगा सभी k into these two are going to give you molarity into normality, molarity into n factor normality na. Therefore I just want to say molar conductivity is equal to K into 1000 by normality into n. Got it? How we play with the concept. Simply reading and following the formulas in the notes, material here, there, okay. So you try to play. So ये numericals, especially for NEET students, numericals जब formulas जो mathematical concepts आते हैं ना, तब आपको डर आता है. So to come out of this, you just play with it. आपको मजा आएगा. So that K into 1000 by N is equal to equivalent conductance. So that molar conductance is equal to equivalent conductance into normality. ये खतरनाक फॉर्मूला है. Understand? Clear? That's good. So आगे बढ़ेंगे. Effect of dilution, very important. So as dilution increases, specific conductivity decreases, molar conductivity increases. It's a trick. Okay, you just see root concentration and molar conductance. A graph. Debye-Huckel-Ansager equation is there. Based on this, I just want to draw a graph at the end of the session. Now here you will be having a straight line like this for a strong electrolyte. You can't say that like that, okay, Ravinder, you just see, I am talking about molar conductance, it is for strong electrolyte. Strong electrolyte, है ना? Whereas for weak electrolyte, that story is different. For strong electrolyte, you can see, you can extend this line, and this line is giving you molar conductivity at a zero concentration. You can decide by using a graph, it is a straight line. For a weak electrolyte, you just see, it goes like this. It's an example, CH3, COOH, weak electrolyte. For a strong electrolyte, as dilution increases, it steadily increases its conductivity, molar conductivity. Whereas for weak electrolyte, there is a sudden increase in the electrolytic conductance. For a weak electrolyte, that gives you a question in the NEET examination. Steady or strong? So steady means it's strong, sudden means it's weak. Are you getting or not? Very good. Now I just want to end up the session by discussing Kohlraasch law. So let us say what this Kohlraasch law says. Limiting molar conductance. What is limiting molar conductance? The conductivity at zero concentration. Can I say what is zero concentration? You take a beaker, 1 spoon of sodium chloride is added. Take a bucket of water, 1 spoon of sodium chloride is added. More diluted, na? Tank of water, 1 spoon of sodium chloride is added. More diluted, na? You take a swimming pool of water, a spoon of sodium chloride is added. Extra diluted, super diluted. You assume Bay of Bengal, Atlantic Ocean, Indian Ocean, entire sea water assumed to be a pure distilled water, assumed to be a pure water, and a spoon of sodium chloride is added. So it gives very less diluted. How much diluted? Infinite diluted. है ना? So at that moment the conductivity is called conductivity at infinite dilution or conductivity at zero concentration or limiting molar conductance. So when sodium chloride is ionized, it migrates independently at a zero concentration, so that molar conductivity of sodium chloride is equal to sum of ionic mobilities of sodium plus ionic mobilities of Cl minus, है ना? This is what is actually called Cold-Rush law. When the ionization is completed at infinite dilution, each ion migrates independently and contributes to its total molar conductivity. That is what is called Cold-Rush law. है ना बेटा? Yes, that's great. Very nice to see. Great students. और एक एग्जाम्पल देना चाहता हूँ आपको. कैल्शियम क्लोराइड gives rise calcium 2 plus and 2Cl minus, and molar conductivity of calcium chloride at a zero concentration is equal to ionic mobility of calcium 2 plus 2 into ionic mobility of Cl minus, क्योंकि 1 molecule of calcium chloride gives 2 molecules of Cl minus. समझ में आ रही क्या है ना? So we are almost come to the end of the session. Practice questions अगले sessions में मिलेगा रविंद्र रेड्डी, because time is very less. Today we are running short of time. Is that fine? So share this amazing video with your friends. We are at the end of the session. Today we discussed the total electrochemistry right from galvanic cell to Faraday's laws, conductance and everything. सिर्फ बैटरीज मिला एंड करोजन मिला है ना बेटा? यस रविंदर. ओके माय डियर स्टूडेंट्स, प्लीज शेयर दिस वीडियोस विथ योर फ्रेंड्स, ज्वाइन इन टेलीग्राम चैनल एंड एक बार लाइक मारो, एंकरेज करो हम लोग को. इतना मेहनत कर रहा है हमारा तरफ सिर्फ आपके लिए, बिकॉज दीज सेशंस आर एब्सोल्युटली फ्री. ओके बेटा, thank you very much. We'll meet more stuff with tomorrow. Organic conversion. Stay tuned. Okay, tomorrow by 1:30. We'll see you. Bye bye. God bless you all.